What if the universe is not one single story told by physics, but a library of different books, each written in its own strange language of reality? It is a question that slips into the mind like a whisper in the dark, unsettling and alluring at once. For centuries, we have comforted ourselves with the thought that nature speaks one universal tongue, that the same laws apply everywhere, from the hearts of stars to the tiniest corner of an atom. But what if that belief is less a truth and more a lullaby? What if it is a human wish spoken into the silence of the cosmos and not a cosmic guarantee? Close your eyes for a moment and picture this. Somewhere far away, farther than telescopes can ever reach, the stars shine under rules that are not our rules. Perhaps their gravity runs differently, or their light bends not quite the same way, or perhaps in that place, atoms cannot bind at all. Such a thought is not just an idea, it is an invitation to step through a doorway. A doorway that opens into a world where physics itself is not universal, but local, shifting, fragile, regional. This doorway is where our journey begins. Physics, as it has been handed down through the centuries, is a promise of order. From the falling apple that stirred Newton's thoughts, to the precise equations of Einstein and the delicate probabilities of quantum mechanics, we have been taught to see nature as a grand design, a system that works the same in every direction and every place. The law of gravity pulls with equal authority on an apple in England, a moon orbiting Saturn, or a star on the edge of a distant galaxy. The speed of light, we are told, is the same in all frames of reference. The fine structure constant, a mysterious number woven into the fabric of electromagnetism, is thought to be fixed everywhere. These laws are the bricks of the cosmic cathedral. And science has told us for centuries that the cathedral is built of unshakable stone. And yet, a quieter possibility waits in the shadows. What if this universality is not a truth, but a perspective? What if the consistency we see is only the consistency of our neighborhood, a small patch of the cosmos where the rules happen to align, while elsewhere, hidden beyond our reach, the laws change? The possibility is as humbling as it is terrifying. It strips away the comfort of absolutes, leaving us adrift in a universe that may not be one stage, but a shifting maze of hidden chambers. Think of standing in a cathedral so vast that you cannot see its walls. You are surrounded by stained glass windows, but you only face one of them. The light streaming through it is familiar, filling the space with blues and golds and soft edges. This is the light you have always known, the light that defines the shape of your world. You assume that all windows must shine this way, that the colors are not just local but universal. But imagine turning, slowly, to another window, one whose glass is cut differently, whose colors are alien, whose light fills the space with hues you cannot even describe. Suddenly, the assumption of sameness collapses. The cathedral is no less real, but it is far stranger than you believed. This is how physics might truly be. Our physics, the rules we know, may be nothing more than the glow from one stained glass window. Beyond our reach, perhaps hidden by unimaginable distances, other windows shine with different lights, casting their own regions of reality in strange, incomprehensible colors. What we call the laws of physics may not be laws at all, but agreements written only in certain places, fragile treaties that hold only within the borders of our cosmic neighborhood. If this is so, then the bedrock of reality is not bedrock at all. It is sand, shifting and unstable, a surface that feels solid beneath our feet, only because we have not yet wandered far enough to see where it crumbles. It is a humbling thought. For all our equations and theories, we may be local creatures in a local world, bound not by universal truths, but by regional conditions. And there is something deeply unsettling in that realization. It echoes with the essence of cosmic horror, the idea that the universe is not designed for us, not even designed for consistency, but a patchwork, stitched together without regard for comfort or comprehension. To stand in such a universe is to feel the ground sway underfoot, to realize that even the constants we cling to may be constant only here, only now. Take a moment to think about this. What does it mean to be alive in a universe where even the rules of existence may change, like weather patterns in an endless storm? What does it mean to know that gravity itself may not be the same everywhere, that the light we trust may be only one dialect among many? It means that we are more fragile than we ever imagined, and yet also more privileged. For in this fleeting, delicate patch of physics, the rules align just enough to allow stars to burn, planets to orbit, chemistry to dance, and consciousness to arise. The cathedral is vast. We've only glimpsed one window, and so the question presses on us with quiet insistence. How could such a thing be possible? What mechanism could weave such shifting fabrics of reality, such differing threads of law and structure? To begin to answer, we must turn our gaze away from our local comfort, away from the reassuring glow of familiar glass, and peer back into the oldest light, the first whispers of creation, the echoes of the Big Bang itself. For it is there, in the beginning, that the possibility of regional physics first emerges. The story of the universe, as science tells it, begins not in silence but in fire. The Big Bang was not a gentle unfolding, but a moment of violent birth, a storm of unimaginable energy expanding into being. We often imagine this beginning as perfect, smooth, uniform, as though the universe were a flawless crystal blossoming outward into eternity. But the deeper we look, the more we realize that perfection was never the universe's way. Creation is not a seamless cloth. It is a quilt, stitched together with irregular threads, patched with uneven fabric, filled with seams and folds that speak of difference rather than sameness. In the first fractions of a second after the Big Bang, something extraordinary occurred, a process scientists call inflation. Space itself swelled at an inconceivable rate, expanding faster than light could ever travel, stretching a subatomic bubble into a cosmos. This expansion was not a calm ballooning, but a turbulent storm, regions of space inflating, freezing, and stabilizing at slightly different moments. Imagine drops of water thrown onto a winter window. Some freeze instantly into jagged ice, others spread and crystallize slowly, each forming a unique shape. That is what inflation may have done to the newborn universe. Different domains froze with different properties, and within those properties lay the seeds of different physics. To picture this, think of a vast plain after a heavy snowfall. From a distance, it looks uniform, white and smooth. But up close, each snowflake has crystallized differently, no two alike. The universe, too, may be like this. From our vantage point, we see only our flake, our patch, and it appears uniform, solid, coherent. Yet beyond our sight, countless other flakes may lie, each formed with its own pattern, each governed by constants and forces that differ from ours. This idea is not just metaphor, but a profound scientific possibility. Inflation theory suggests that the values of physical constants, the strength of gravity, the charge of the electron, the very speed of light, might not be written in stone, but instead set differently in each frozen domain. One region might see gravity so strong that stars collapse instantly into black holes. Another might have gravity so weak that galaxies could never form at all. In some places, atoms may refuse to bind, and chemistry itself could be impossible. In others, perhaps exotic laws emerge, laws beyond our ability to imagine, where the familiar categories of matter and energy mean nothing. And so, the universe becomes less like a singular story and more like a library, a collection of countless books, each written in a different language of physics. Our own patch is merely one volume, legible to us only because we live inside its words. But the shelves stretch beyond sight, and most of the books are unreadable, incomprehensible, filled with rules that could never give rise to readers. There is a strange beauty in this, but also an unease. For if the cosmos is a patchwork quilt, then our sense of universality is a fragile illusion. We live inside one square of fabric, and because the threads here are tightly woven, we mistake them for the whole tapestry. Yet the quilt spreads infinitely, stitched from patterns we cannot fathom, many of them jagged, broken, sterile. The horror arises not from monsters or shadows, but from the realization that order is not guaranteed, that what we call the laws of nature may be nothing more than the temporary stitching of one region, holding together for now. Take a moment to reflect on this. Imagine that just beyond the horizon of our visible universe lies another patch, stitched to ours, yet governed by rules that make no sense to us. Imagine a sky where light does not move at our speed, or a place where time itself refuses to flow. Imagine walking across a field and stepping through an invisible border, only to find that the physics you relied on a moment ago has dissolved, replaced by something alien. The mind resists this thought, clinging to the comfort of consistency, yet the possibility remains, deep and haunting. The implications are staggering. If inflation created countless frozen domains, then the multiverse is not a fantastical dream but a natural outcome. Not universes stacked far apart, but regions of spacetime lying side by side, each stitched from a different physics. In such a reality, our own existence is not guaranteed, but accidental. We live in a patch where the constants happen to align in a way that allows stars to burn slowly, water to flow, and life to blossom. But this patch is not special in the eyes of the cosmos. It is only one thread among endless others, and the fact that it suits us is simply because we are here to notice it. This is where science brushes against philosophy, and where philosophy trembles at the edge of horror. For if our laws are not universal, then what does it mean to say that we understand the universe? We do not. At best, we understand one small corner, one fragile arrangement of numbers and forces, a single snowflake among billions. Beyond that, there may be endless regions that defy not only our equations, but our very imagination. And yet, even within this unsettling possibility, there is wonder. The idea that the cosmos is a quilt means that creation is richer than we thought, stranger and more varied. It means that reality is not a monotone, but a symphony of many keys, some harmonious, others discordant, most unheard by human ears. Our patch is not the whole, but it is ours. And in it, the physics has arranged itself just so, long enough for us to ask these questions, to feel awe, to feel dread, to wonder. The universe we see is not uniform perfection. It is stitched together from difference, from irregularity, from frozen accidents that became structure. It is both fragile and infinite, both comforting and unsettling. To live inside it is to stand on shifting sand while gazing up at an endless quilt of stars, each patch whispering a different truth. And so another question rises gently to the surface, waiting with quiet insistence. If the cosmos is truly stitched from many fabrics, if physics itself can change from one patch to another, then why does our own square of the quilt appear so consistent? What holds our laws together so firmly that, from our perspective, they feel eternal? To answer that, we must look more closely at the fabric itself, at the threads we call constants, and ask whether they are as unchanging as they seem. The very word constant suggests comfort. It suggests something steady, unchanging, a foundation that endures no matter what storms may come. In physics, constants are supposed to be the bedrock, the silent rules beneath all the dancing of matter and energy. They are the numbers that do not bend. The speed of light, fixed at 299,792 kilometers per second. The gravitational constant, holding the stars in their celestial embrace. The fine structure constant, that strange, dimensionless number that determines how light and matter interact. These are not supposed to be negotiable. They are the deep grammar of the universe, the notes on which the cosmic symphony is written. But what if they are not so steady after all? What if these constants, far from being fixed, drift across time and space like instruments that slowly slide out of tune? Imagine a violin whose strings are never tuned once and for all, but instead change ever so slightly with each passing moment, each change of temperature, each subtle shift of tension. At first, the difference is imperceptible. The melody remains sweet, the harmony intact. But over time, the notes falter, the chords clash, and the music begins to dissolve. The idea that constants might not be constant is a thought that rattles the spine. It is as though the floor beneath your feet might shift, not suddenly but slowly, almost imperceptibly, until one day you discover that the ground no longer holds where you thought it did. For decades, physicists have explored this possibility, searching the sky, the atoms, the light from ancient stars, to see if the numbers that rule our world might have changed. The fine structure constant, known by the Greek letter alpha, is one of the most haunting examples. This number governs the strength of the electromagnetic force, the force that shapes chemistry, electricity, the very light by which we see. If alpha were only slightly different, atoms could not hold together, stars would burn too quickly or not at all, and life as we know it would be impossible. In our equations, alpha is written as if eternal, but observations of light from distant quasars, billions of years old, suggest that alpha may not be quite the same in every direction. Some measurements whisper of tiny shifts, as if in certain corners of the cosmos, alpha hums a slightly different tune. Even the speed of light, that sacred constant of Einstein's relativity, has been questioned. Could it be that light traveled differently in the early universe, or that it drifts in its value across vast gulfs of space? If so, the very geometry of reality trembles, for relativity rests on the certainty of light's speed. Without that certainty, causality itself may blur, and the rhythm of time may no longer beat evenly. And what of gravity, the gentlest yet most commanding of forces? Its strength seems constant here, in our lives, in our solar system, in the motions of galaxies. But the idea has been raised that gravity might evolve, its pull waxing and waning across the eons. If gravity were just a little stronger, stars would collapse more easily, compressing into black holes. If it were weaker, galaxies would unravel before they could form. The balance is razor thin, and yet we assume it to be fixed, eternal. But what if that balance is maintained only locally, only for now? Take a slow breath and sit with this thought. If the constants shift, even by the smallest fraction, then the universe itself is alive with instability. The stars above us are not secure furnaces burning forever on steady fuel. They are delicately balanced fires, poised on the edge of collapse or extinction, depending on the numbers that govern them. The chemistry of life, the delicate folding of DNA, the way oxygen binds in our blood, all of it is tuned to the music of constants. If the notes drift, then so too does the possibility of life. We are suspended on a thread, a fragile tuning, in a universe that may never have promised us stability at all. There is a quiet horror in this, but also a strange kind of beauty. It means that reality is not carved from stone, but alive, shifting, perhaps breathing. The constants are not chains, but currents, moving subtly through the ocean of being. We exist because, for now, these currents flow gently enough to allow complexity, to allow fire, water, thought, and love. Yet beneath that comfort is the awareness that they may change, and that everything we know could unravel with them. Scientists wrestle with this possibility not because they wish it to be true, but because the evidence occasionally teases it. Light from the farthest reaches of the cosmos carries with it the memory of conditions billions of years ago. In that light are whispers of whether the constants were the same then as they are now. The results are not always clear. Some experiments suggest slight drifts, others deny them, the debate ongoing. But even the possibility that constants might be local rather than universal reshapes our understanding of existence. If constants can vary, then our laws of physics are not eternal decrees, but regional customs. They are not truths carved into the bones of the cosmos, but agreements that hold only here, only now, in our small patch of the quilt. Beyond, in other domains, the tuning may differ, and with it, the very fabric of reality. Think of walking through a landscape where the air grows thinner as you climb a mountain. At first, you do not notice. Your breath comes easily, your heart beats steady. But slowly, subtly, the pressure changes, and before long, each breath becomes a struggle. In another place entirely, the air might be so thin that no breath is possible, no life sustainable. The constants are like that air. Here, in our valley, they are thick enough, rich enough, tuned just so to allow us to breathe. Elsewhere, they may not be. This realization brings us back to a profound humility. We are not the masters of a stable cosmos, deciphering eternal truths. We are delicate guests living in one fragile arrangement of numbers, one fleeting balance of forces. The horror is not that the universe is hostile, but that it is indifferent, its rules not written for us, not even written to last. And yet, in this fragility, there is wonder. To know that everything we see and feel rests on the thin ice of constants makes our existence no less real, only more precious. The stars burn, the oceans move, our hearts beat, all because the cosmic violin is tuned just so. One day, perhaps, the notes will drift, the music will change. But for now, in this moment, the melody is ours. And so the question arises, gentle but insistent. If constants may shift, where do we find the first hints, the first cracks in their stability? The answer lies not in our local world, but in the ancient light that has traveled across the universe for billions of years, carrying with it the memory of beginnings. It is there, in the afterglow of creation, that the whispers of change may first be heard. Every night, when we look into the sky, we are gazing into the past. The stars above us are not what they are now, but what they were years, centuries, even millennia ago. Light, though swift, takes time to reach us. And in that time, the stars themselves may have changed. This means that when we look outward, we are also looking backward through layers of cosmic memory. And if we look far enough, past the stars and the galaxies, past the clusters and voids, we eventually reach a boundary. Not a wall, not a solid barrier, but a veil of ancient light that marks the universe's earliest visible moment. This veil is called the cosmic microwave background, the CMB. It is the afterglow of the Big Bang, the soft embers that remain from a fire that burned almost 14 billion years ago. It is faint, almost ghostly, spread evenly across the sky in every direction. If you could tune an old television set between channels, some of the static you would see comes from that ancient light, photons still humming through space since the dawn of time. At first, scientists believed the CMB was perfectly uniform, a smooth glow without blemish, like a flawless fog. And for a while, that made sense. If the universe began in a single explosive moment, then the afterglow should be the same everywhere. Perfection seemed natural, even expected. But as our instruments grew more sensitive, as satellites like COBE, WMAP, and Planck turned their eyes to this ancient background, a different picture began to emerge. The glow was not perfectly smooth. It was marbled with faint irregularities, tiny fluctuations in temperature, subtle differences in density. And within those irregularities lay secrets that continue to haunt cosmologists. These fluctuations are not large. They are differences of mere millionths of a degree. And yet, they matter. For out of them, the structure of the universe would grow. Where the CMB was slightly denser, matter would later gather to form galaxies and clusters. Where it was thinner, voids would stretch. These slight variations are the fingerprints of creation. They show us that the universe, even in its infancy, was never perfect, never entirely uniform. But there is more than simple irregularity. The CMB carries with it anomalies, alignments, and patterns that should not exist if the laws of physics were truly universal and absolute. Imagine gazing at a painting, each brushstroke laid down in careful symmetry, only to find one stroke that juts across the pattern, breaking the harmony. The whole picture is still beautiful, but it now carries a question, a dissonance. Why is this stroke different? Why does it not obey the same rules? One of these strange features is known as the axis of evil. It is not evil in the way of stories, not a force of malice, but a name given by scientists to a puzzling alignment. When we map the CMB across the whole sky, certain large-scale patterns appear to point in a particular direction, as though the universe itself were tilted. This should not be. The universe, according to our models, should be isotropic, the same in every direction. Yet the CMB whispers of an orientation, a cosmic preference, a tilt that defies our expectations. There are also cold spots, vast regions where the CMB is lower in temperature than the surrounding light. One in particular, the so-called cold spot, is so large and so deep that it resists simple explanation. Perhaps it is the result of an enormous void in space, an absence of matter stretching across billions of light years. But some suggest it might be something more radical, a bruise from a collision with another universe, a scar in the fabric of the CMB that tells us our patch of physics has brushed against another. These anomalies are not easy to dismiss. They persist across different measurements, different instruments, different satellites. Each new observation confirms that the CMB carries subtle irregularities, brushstrokes that do not belong to the uniform canvas we expected. What do these whispers mean? Perhaps they suggest that the laws we call fundamental are not universal decrees, but local arrangements. That what we see as absolute may be only regional, stitched into place by the conditions of our patch of the cosmos. The CMB, instead of being a perfect relic of a universal law, becomes a reminder that the universe may have begun unevenly, asymmetrically, and that the very rules we trust may not extend beyond our horizon. There is something deeply unsettling in this. For if even the oldest light, the most ancient record of creation, carries signs of broken symmetry, then what faith can we place in our constants, our equations, our cherished laws? We may live inside a pocket of order, but the fabric beneath us may ripple with hidden currents. Take a moment to picture this. You are standing before a great tapestry, woven with care. From a distance, it seems seamless, patterns repeating, colors balanced. But as you step closer, you see that certain threads do not align. A line of color twists where it should flow straight. A knot breaks the rhythm of the weave. The tapestry is still beautiful, but no longer perfect. It speaks not of a flawless plan, but of a patchwork stitched together from difference. That is the CMB, the cosmic tapestry that reveals the universe's earliest imperfections. The implications extend beyond science into philosophy. If the laws of physics are regional, then the dream of finding a single, unified theory that explains everything may be just that, a dream. Instead of one grand equation, we may find a library of equations, each governing a different domain, none of them universal. The quest for unity may give way to the acceptance of plurality, of patchwork. And with that acceptance comes humility. We may not be deciphering the laws of reality itself, but only the laws of our neighborhood, our fragile corner of the quilt. Yet within this humility lies wonder, for it means that the universe is not less, but more varied, more strange, more filled with possibilities than we can imagine. The CMB, with its irregularities, does not diminish the grandeur of the cosmos. It deepens it, reminding us that creation is not a smooth perfection, but a living, shifting process filled with seams and scars and whispers of the unknown. And so, as we listen to these whispers from the ancient light, we find ourselves drawn deeper into mystery. If the afterglow of the Big Bang carries signs of broken symmetry, then what of the particles that compose reality itself? Do they too whisper of change, of instability, of laws that are not eternal, but regional? Imagine a pair of dice resting in the palm of a hand. The dice have not yet been thrown. They hold a kind of suspended potential, a future waiting to be chosen. Now imagine the hand opens, the dice fly. They tumble across the table, clattering and spinning until they finally come to rest, revealing numbers that could not have been known before the throw. For most of human history, the universe was imagined as a place where dice were never thrown, where everything was clockwork and predictable. If the starting position was known, then the outcome could be calculated. But then came the 20th century, and with it, quantum physics. And suddenly, the dice were everywhere. At the heart of quantum physics lies an unsettling truth. Reality, in its smallest scales, does not behave deterministically. The building blocks of the cosmos do not follow strict paths like tiny billiard balls on a table. Instead, they flicker, blur, and waver between possibilities. An electron may be here, or there, or both, until the moment it is observed. A photon may take one path, or two, or every possible path, all at once, until its wave of possibility collapses into a single outcome. Quantum mechanics does not describe certainty. It describes likelihood, probability, the rolling of cosmic dice. This idea was so shocking that even Albert Einstein resisted it. He famously declared that God does not play dice with the universe. To Einstein, the notion that reality itself was probabilistic, that the world was not governed by strict cause and effect but by chance, was unacceptable. He believed that beneath the apparent randomness there must be hidden laws, unseen variables, some deeper clockwork that restored order. But a century of experiments has shown otherwise. From the double-slit experiment to entanglement tests, from Bell's inequalities to quantum tunneling, evidence piles up that the dice are real. Reality is not a single track, but a casino floor, dice rolling in endless throws. What does this mean for the idea of universal laws? If the smallest building blocks of matter already resist determinism, if they move not by rules but by probabilities, then why should the larger scales of the cosmos be absolute? Perhaps the laws we imagine as fixed are not commandments but averages, statistical habits of a universe that tends towards certain outcomes without guaranteeing them. Take a moment to reflect on this. The world around you feels stable. The floor beneath your feet is solid, the air in your lungs dependable, the sun predictable in its rising and setting. And yet, beneath this comfort lies a restless quantum sea, particles blinking in and out of existence, probabilities resolving into momentary certainties only to dissolve again. Everything you see, everything you touch, is woven from dice rolls that never stop tumbling. The implications of this are both humbling and profound. We tend to imagine laws of physics as eternal, etched into the fabric of the cosmos like scripture. But quantum mechanics whispers that perhaps reality is not a book of laws, but a collection of tendencies. The universe does not say, "This must happen." It says, "This usually happens." The difference is subtle, but it changes everything. It means that the cosmos is not a fixed stage, but a living probability, forever in motion, forever unresolved. This idea bleeds quickly into philosophy. If reality is probabilistic, then what is truth? What does it mean for something to be real if it can exist in multiple states at once, if it can only be pinned down in the act of observation? Perhaps reality is less like a stone, hard and unchanging, and more like a cloud of mist, shifting and reforming depending on how one looks. And if that is so, then the search for ultimate laws may be misguided. Perhaps there are no ultimate laws, only patterns of preference, like the rhythms of a river or the habits of a flock of birds. Quantum indeterminacy also invites us to rethink our place in the cosmos. We often feel that humans are small, powerless, drifting in a vast universe indifferent to our existence. But in quantum mechanics, the act of observation matters. The outcome of an experiment, the collapse of a wave function, depends on whether and how it is observed. At the smallest scales, reality itself seems to respond to the act of being seen. This is not to say that consciousness controls the universe, but it does suggest that the universe is participatory, that its fabric is not complete without interaction. Think of Schrödinger's cat, that famous thought experiment. A cat is sealed in a box with a quantum device that has a 50% chance of releasing poison. Until the box is opened, until the quantum state is observed, the cat is both alive and dead. Not alive in one timeline and dead in another, but in a strange in-between, both possibilities entwined. Only when the box is opened, only when observation occurs, does the universe choose. The metaphor is unsettling because it forces us to confront how deeply probability shapes reality. The universe is not a fixed story written in advance. It is a branching narrative, each roll of the dice determining the next line. And if this is true at the smallest scales, then why assume it ends there? What if the quantum dice do not only decide the spin of electrons or the decay of atoms, but also, in some vast sense, the larger laws that govern entire regions of space? If even the tiniest particles are not bound by certainty, then the great laws of physics themselves may be subject to variation. Perhaps they are not universal, not eternal, but outcomes of deeper cosmic dice rolls. This thought stretches the imagination to its edge. It suggests that what we call physics may not be fixed, but regional, each patch of the cosmos shaped by different rolls of the dice, different probabilities settling into different tendencies. In one region, the dice fall one way, yielding the constants we know, the chemistry we rely on. In another, the dice fall differently, and the rules are not our rules, the laws not our laws. The universe becomes less like a single machine and more like a casino of endless tables, dice tumbling across infinity, each throw creating a different game with different rules. Pause here and let that image settle. An infinite casino, every table lit by different lamps, every game played with dice that tumble forever. You and I sit at one particular table, in one particular pool of light, watching the dice of our physics tumble. But all around us, in rooms we cannot yet enter, other games play on, other dice roll, other outcomes shape other realities. The comfort of certainty dissolves in this vision, but it is replaced by something else: wonder. For if reality is woven from dice, then the cosmos is not less meaningful, but more. It is not a rigid mechanism, grinding out predetermined results, but a living, shifting, endlessly creative play. It is not a book with a single ending, but a library of endless stories, each rolled into being by chance. And so we return to the question of universality. If quantum dice roll everywhere, then what if they roll differently in different regions of the cosmos? What if the constants we take for granted are just the outcome of our table's game, while elsewhere, the dice have landed on utterly different numbers, utterly different rules? For as long as humans have gazed at the night sky, they have wondered, are there other worlds like ours? At first, the question meant other lands across the sea, then other planets circling distant stars. But today, the question stretches further than ever before. Could there be other universes, hidden just beyond the reach of our senses? The idea is called the many worlds hypothesis, a notion born from the strange mathematics of quantum physics. In its most familiar form, it suggests that every quantum event, every roll of the dice, creates a branching reality. One world where the particle spins left, another where it spins right. One world where you make a choice, another where you don't. The universe, according to this picture, is a tree that grows endlessly, each branch a new reality. For most people, this idea is already disorienting. The thought that there may be countless versions of ourselves scattered across endless timelines is dizzying enough. But what if the branching does not only create different outcomes within the same physics? What if each branch carries its own rules, its own constants, its own laws of nature? Then the Tree of Worlds is not merely a collection of alternate histories. It is a forest of alien realities. Imagine standing before a great oak. Its trunk is thick and familiar, its roots sinking into the soil of the physics we know. But as your eyes travel upward, you see the branches split and divide, each one veering in its own direction. On one branch, gravity is stronger, pressing stars into collapse before galaxies ever form. On another, time runs backwards, entropy decreasing instead of increasing, a world where cause follows effect instead of preceding it. On another, light itself never exists, and the universe is blind, dark, incomprehensible. This is not a tree of timelines, but a tree of laws. To live in such a multiverse is to live in a sea of existential possibility. Our world becomes one library book among countless others, each written in a different language, each governed by a different grammar of reality. Some books would be coherent, their physics allowing structures, chemistry, life. Others would be gibberish, unreadable, worlds that collapse almost as soon as they begin, universes where even the concept of beginning may not apply. There is something deeply unsettling about this vision. Science fiction has long played with the idea of parallel worlds, but usually these are familiar variations. A world where history took a different turn, where one battle was won instead of lost, where societies rose or fell in alternate patterns. But those are worlds still bound by the same physical rules. In a cosmos of parallel rules, the variations are far more extreme. These are not universes where Rome never fell or where humanity never evolved. These are universes where the very building blocks of thought and matter cannot exist. Worlds without atoms, worlds without time, worlds where even causality, the chain of this leads to that, disintegrates. Take a moment to sit with this idea. Imagine trying to conceive of a place where cause does not precede effect, where events blossom out of nothing, without sequence. It is almost impossible for the human mind to grasp, for our thoughts themselves are chained by causality. And yet, if physics is regional, then perhaps such realms are not only possible, but inevitable. They may exist, unseen, branching beside us, alien to the core. The horror here is subtle but profound. It is not the horror of monsters lurking in shadows, nor of apocalypse raining down upon our world. It is the horror of irrelevance, of fragility. For if universes with alien rules exist, then ours is not central, not privileged, not even necessary. We are one arrangement among countless arrangements, and perhaps not even a common one. Life, consciousness, beauty, all may be rare anomalies, flukes born from a lucky roll of cosmic dice in one hospitable patch of physics. Elsewhere, the dice fall differently, and nothing even remotely familiar can ever arise. Philosophers once imagined reality as a grand, orderly cathedral, its pillars rising in symmetry, its windows filled with light. But the vision of parallel rules tears down that comfort. Reality becomes more like an endless labyrinth, with passages that twist and dissolve, some leading to gardens, others to dead ends, many collapsing into darkness. To know that such a labyrinth may exist all around us, invisible but adjacent, is to brush against cosmic horror in its purest form. And yet, there is wonder here too. Because if such worlds exist, then the cosmos is more creative than we have dared to dream. It is not merely vast in space and time, but vast in possibility. Every strange equation, every impossible idea, every nightmare and every dream may find a home somewhere in the branching multiverse of rules. The universe is not a single symphony, but an orchestra of countless instruments, many of them playing in keys we cannot hear. This perspective reshapes even the way we think about meaning. In a cosmos with one set of laws, one fixed stage, meaning is a search for universality. But in a cosmos of many rules, meaning may be local, fragile, fleeting. Perhaps the task is not to find eternal truths, but to marvel at temporary harmonies, to cherish the delicate patterns that emerge in our particular branch. Consider the possibility that our universe, with its balance of gravity, light, chemistry, and time, is a rare oasis. Most branches may lead to barren outcomes, uninhabitable deserts of physics. But here in this branch, the dice fell just so, and stars ignited, planets formed, life arose, consciousness bloomed. To realize this is to feel a double weight: gratitude for the strangeness of our existence, and a quiet terror at how easily it might have been otherwise. If parallel rules exist, then they cannot be entirely unreachable. For though we may never walk into those alien realms, their existence may leave traces, faint signatures, whispers that cross the boundaries. Just as the cosmic microwave background carries anomalies, perhaps the silence between galaxies carries echoes. Perhaps the voids themselves, the vast expanses where matter is thin and light seldom travels, hide the scars of collisions between different rules, different fabrics of physics brushing against each other. The thought lingers. How do we listen for such whispers? How do we tell if the silence is ordinary silence, or the shadow of another universe's law pressing faintly against ours? When we look at the night sky, what we see is not the universe as it truly is, but only the brightest parts of it. Stars glitter against the darkness, galaxies form delicate spirals, clusters glow faintly in telescopes. But all of these luminous things, for all their grandeur, are only the embroidery on a far larger fabric. The deeper reality of the cosmos is not stars, not galaxies, not even clusters. It is emptiness. Vast stretches of space, unimaginably wide, contain almost nothing at all. These are the cosmic voids, the gulfs between the filaments of the cosmic web. Imagine a spider's web stretched across the night. Bright threads of galaxies and clusters form the strands, but between them lie yawning gaps, dark and vacant. These voids are not small. Some span hundreds of millions of light years across. Entire galaxies could fit within them by the thousands, and yet almost none are there. They are deserts of space, oceans of silence. At first, astronomers thought these voids were simply empty, nothing more than the natural consequence of matter clustering under gravity. But as observations grew more detailed, anomalies began to appear. Galaxies at the edges of voids seemed to move in strange ways, flowing in unexpected directions, as if drawn by unseen currents. Some voids appeared colder than they should be, their cosmic microwave background light dimmed in puzzling patterns. These anomalies suggested that voids are not passive, but active. They may be boundaries, borders where something strange happens, where the laws we take for granted begin to shift. Picture the universe as an ocean dotted with islands. On each island, life thrives under its own rules, its own traditions, its own weather. But between the islands lies the sea, vast and dangerous, where rules dissolve, where navigation falters, where the familiar landmarks vanish. The cosmic voids are that sea. They are not merely absences of matter, but regions where the fabric of physics may be thinner, looser, less constrained. Consider the possibility that the constants we trust, the strength of gravity, the behavior of light, the ratios of fundamental forces, hold steady only within the denser filaments of the cosmic web. Outside, in the voids, they might begin to drift. Like ink fading at the edges of a page, the sharpness of our laws may blur in the deep emptiness. Galaxies flowing strangely at void boundaries might be hints of this blur, caught in the tug-of-war between our rules and those of the neighboring expanse. This idea transforms our vision of the universe. Instead of a calm, uniform sea with galaxies scattered evenly, the cosmos becomes an archipelago, each island governed by hidden variations in law. Our region may be stable, like a fertile land where life can flourish, but just beyond, across the Gulf, another island may follow slightly different rules. In some, stars may burn brighter, but live shorter lives. In others, chemistry itself may unravel, molecules failing to hold together. The voids between these islands are not mere distances, but thresholds, borders where one domain ends and another begins. There is a quiet dread in this thought. We often imagine space as dangerous because of what it lacks. No air to breathe, no warmth to sustain us, no gravity to hold us. But this danger is still familiar, governed by the same physics we know. What if beyond the familiar darkness lies not just emptiness, but strangeness? A realm where the very rules of being do not apply, where the constants bend into shapes we cannot recognize? The voids may not simply be deserts. They may be doorways. Pause for a moment and imagine drifting into such a void. At first, the emptiness seems ordinary. Stars receding behind, fewer galaxies ahead. The silence deepens. Then, slowly, imperceptibly, things begin to feel wrong. The light of distant galaxies bends oddly, as if refracted by invisible glass. Instruments no longer agree, their measurements diverging. A star that should shine at a certain brightness flickers differently. a clock ticks slower or faster, or perhaps both, depending on where you look. You realize that you have left not only the crowded island of galaxies, but also the familiar laws that hold them together. You are crossing into another fabric, another rule set, and what lies ahead is not merely dark, but alien. To some, this might sound like fantasy, but the universe has already shown us how fragile uniformity can be. The cosmic microwave background carries anomalies that defy perfect symmetry. The fine structure constant may drift ever so slightly over time and space. If these whispers are true, then the voids, those vast, silent expanses, are the most natural places to search for deeper shifts. Where matter is thin, the scaffolding of physics might loosen, revealing glimpses of alternative rules. Philosophically, this vision is haunting. We humans often cling to the idea that the universe is one unified whole, that what is true here is true everywhere. But the voids suggest something different, that reality may be fractured, compartmentalized, stitched together from regions of varying law. To live in such a cosmos is to live not in a single story, but in a collection of stories, each with its own grammar, separated by blank pages of silence. And if this is so, then our universe is precarious. We dwell on one island of stability, but it is surrounded by gulfs that may not sustain us. We are like sailors on a fragile raft, floating through seas that may lead not to new lands, but to waters where the very idea of sailing dissolves. The archipelago of physics is vast, but most of it may be uninhabitable. Yet, even within this dread, there is wonder. Because if the voids are borders, then they are also invitations. They suggest that the cosmos is more layered, more mysterious, more varied than we can grasp. Each void becomes not just a silence, but a hint of other possibilities. Perhaps, hidden in their depths, are signatures of collisions between different islands of law, scars where one reality brushed against another. Perhaps, in the anomalies we see at their edges, we are already glimpsing the outlines of alien rules pressing faintly against our own. The thought lingers like a shadow at the edge of vision. The universe is not a calm sea, but an archipelago, its islands separated by gulfs that may hide other laws, other fabrics. And if islands exist, then the question follows naturally. What happens when they collide? There are moments in life when we brush against something we cannot quite name. The faintest ripple at the edge of awareness, a sense that something vast has passed close by, invisible but undeniable. For cosmologists, the universe itself may carry such ripples. Hidden in the faint afterglow of the Big Bang, in the soft radiation of the cosmic microwave background, there may be bruises, scars left behind by collisions not with asteroids or galaxies, but with other universes. The idea sounds almost too strange to say aloud, yet the mathematics of cosmic inflation opens the door. In the earliest fraction of a second, the universe is thought to have expanded faster than the speed of light, ballooning from subatomic size to cosmic scale. But inflation, according to many models, does not happen just once. It happens in bubbles, patches of space-time inflating separately, each one budding into its own universe. Ours is one bubble, vast and luminous, but not necessarily alone. Other bubbles may have formed, grown, and drifted outward in the sea of inflation. And when two bubbles meet, their edges collide, leaving a scar. Imagine water brought to a boil. Bubbles form in the roiling liquid, each one swelling and expanding until it presses against its neighbors. Where they touch, the surface warps, a boundary is formed, sometimes even a rupture. If our universe is a bubble, then the cosmic microwave background might be the place where such collisions reveal themselves. The afterglow, though nearly uniform, carries faint anomalies, cold spots, and asymmetries. Some physicists suggest these may be bruises, signs that another universe pressed against long ago, leaving behind a faint memory in the light we now see. The most famous of these is the so-called cold spot. First noticed by the WMAP satellite and confirmed by Planck, it is a region of the sky where the microwave background is significantly cooler than average, spanning a patch of space hundreds of millions of light years across. At first, it was thought to be the result of an unusually large void, a vast underdensity of matter sapping energy from passing light. But subsequent studies suggest the void alone cannot explain it. Something else may be at play. One possibility, strange and unsettling, is that this cold spot is a scar left by a collision between our bubble universe and another. If this is true, then the implications are staggering. It means our universe is not isolated, not sealed away in perfect solitude. It has neighbors, and those neighbors may brush against us. The laws we hold as constant may not only shift within, but be altered from without, reshaped by encounters with alien physics. The borders between universes are not impenetrable walls, but thin membranes, fragile and vulnerable. Take a moment to imagine this. Picture yourself inside a soap bubble. Its surface gleams with rainbow light, delicate yet enclosing. From within, the bubble feels infinite, the whole world contained in its fragile sphere. But then, drifting closer, another bubble presses against it. For a moment, the two spheres touch, their surfaces warping, a ripple spreading across their skins. To us inside, that ripple might feel like a sudden scar across the sky, a cold bruise in the cosmic afterglow. And then, just as quickly, the other bubble drifts away, leaving only the trace of contact. The fragility of this vision is difficult to escape. If universes collide, what does that mean for us, creatures who rely on stability? Could a collision alter the constants of our world, shift the rules of chemistry, extinguish the balance that allows stars to burn? The thought is terrifying, but most models suggest that the collisions we could detect happened long ago, in the deep past, when our universe was still young. What we see are the scars, not the active wounds. The bruises are reminders, not ongoing battles. And yet, the knowledge that such brushes are possible makes our reality feel less eternal, less secure. Philosophically, the idea is even more unsettling. We often think of the universe as self-contained, a grand totality of existence. But if bubbles collide, then our universe is not the whole. It is a part, one chapter in a book with countless others, some overlapping, some pressing against our margins. Reality itself becomes porous, subject to intrusion. What we call the laws of physics are not sovereign but contingent, upheld only so long as our bubble remains unbroken. And perhaps in some regions, collisions do more than leave bruises. Perhaps there are universes whose contact is catastrophic, rupturing the membrane, blending two sets of rules into something neither fully ours nor theirs. For us, this is speculation, but in the mathematics of inflation, it is not forbidden. There may exist domains where physics itself is hybrid, stitched from the aftermath of cosmic collisions. In those realms, the laws might not only be regional, but recombinant, forever altered by the brushing of bubbles. It is worth pausing here to let this vision breathe. Imagine a night sky not filled with stars, but with faint scars, each one the mark of a cosmic encounter. Imagine knowing that the world you inhabit carries within its very light the memory of a time when reality itself was bruised. It is a thought both haunting and sublime, filling the silence of space with echoes of unseen neighbors. And there is something deeply humbling in this. If universes can collide, then ours is not supreme, not eternal. It is fragile, like a soap bubble, like a bruise that might fade. To live within such fragility is to live with awe, to recognize that existence is not guaranteed, that the balance we rely on is precarious. The laws we call fundamental may not be fundamental at all. They may be local, temporary, and vulnerable to forces beyond imagining. The image returns, bubbles in a boiling sea, pressing, touching, drifting away. Each one holds a world, a reality, a set of laws. Each one fragile, each one temporary, each one part of a larger churning ocean we cannot yet see. Our bubble has survived, and in that survival, life has blossomed. But the bruises remind us, survival is not guaranteed, and beyond our thin shell lies an infinite ocean of possibility. And if even the collision of universes is possible, if scars of alien laws can press into our own, then the fragility of reality grows deeper still. For what we call time itself, the rhythm of before and after, the heartbeat of existence, may not be a universal law at all, but only a local arrangement. Perhaps time itself is regional, flowing differently, or not at all, in other domains. Time. It feels so intimate, so unquestionable. Every heartbeat measures it. Every thought is carried along by its current. Every memory is a stone set into its riverbed. To live is to move through time. Yet for all its apparent universality, time may be a local arrangement, fragile and conditional, rather than a fundamental law. It is possible that what we call the flow of time is not the universe's eternal drumbeat, but the rhythm of a particular corner of reality, a song sung only here, under particular conditions, for a fleeting moment. Einstein opened the door to this realization. Before him, time was treated as absolute, the same for everyone. everywhere. But relativity shattered that picture. Time, Einstein showed, is not independent but malleable. It stretches in the presence of gravity and shrinks when you move quickly. Astronauts orbiting Earth age ever so slightly slower than those who remain on the ground, their clocks diverging by fractions of a second. Near a black hole, time slows to a crawl, so that an observer who lingers near the event horizon experiences moments that, to someone watching from afar, span millennia. The lesson is unmistakable. Time is not universal. It is relative. But if relativity teaches that time flows differently in different conditions, then perhaps the idea can be taken further still. Perhaps time itself is not guaranteed. What if there are regions where time simply fails to exist, places where cause and effect dissolve, where the very idea of before and after evaporates into nothing? Imagine a desert. In one region, the sand lies firm and packed, forming paths one can walk. But further out, the dunes shift constantly, erasing footprints, blurring all traces of movement. Walk further still, and the sand is swept away entirely, leaving a barren plateau where no trail can ever form. Time might be like that. In some regions, it is firm and measurable, each moment building upon the last. In others, it drifts and blurs, less certain, less structured. And perhaps, in the deepest reaches of the cosmos, it vanishes altogether, leaving a timeless expanse where nothing happens because happening requires time. Quantum mechanics hints at this possibility. At the smallest scales, the notion of time becomes slippery. Equations that describe particles at the quantum level often work perfectly well without explicitly including time. Instead, they describe correlations, probabilities, states of being. Time appears not as a foundation, but as a byproduct of relationships. Some physicists even argue that time emerges from entanglement, the weaving together of quantum states. If so, then time is not the canvas of reality, but a pattern embroidered onto it. And like any embroidery, it might cover only part of the fabric. Take a moment to sit with that. The most intimate thing we know, the thing we trust with every breath, might be nothing more than a regional phenomenon. Like a breeze that blows here but not there, like a tide that rises only in one bay but leaves the rest of the ocean flat. The implications are dizzying. A cosmos where time is not universal is a cosmos where our very sense of existence is provincial. We live in a region where time flows, where causes precede effects, where memories can exist. But beyond, in the deep gulfs of the cosmos, there may be domains where time is absent. What would that mean? To enter such a region might be to step outside of history. Clocks would stop, not because they are broken, but because the concept of ticking itself no longer applies. A thought would never begin, never end. Motion would be meaningless, since movement requires sequence, and sequence requires time. Philosophers have long wrestled with the idea of eternity, but eternity, in the classical sense, still presupposes time, an endless succession of moments. True timelessness is stranger. It is not endless time, but the absence of time altogether, an unbroken stillness beyond all becoming. In such a place, nothing changes, nothing decays, nothing is born. The very fabric of reality could be frozen, not in stasis, but in something deeper, absence of progression. This vision can feel comforting at first, like a promise of rest, but linger on it, and it becomes unsettling. For without time, there can be no memory, no anticipation, no experience. Consciousness itself might unravel, for to be conscious is to move from one thought to the next, to inhabit a sequence. In a timeless region, mind may be impossible. And yet, perhaps, this is not entirely alien. We touch echoes of timelessness in our own experience. In deep meditation, when the sense of minutes passing dissolves into a single eternal moment. In dreams, when events unfold without clear sequence, when causality flickers and fades. Even in waking life, when we are lost in beauty or in grief, time can feel elastic, collapsing or stretching until its flow is uncertain. These moments are only shadows, but they hint that time may not be as absolute as we think, that it is a property of perception, of relationship, of region. What would it mean if time is not everywhere? It would mean that the universe is not a river flowing from source to sea, but a landscape of springs and dry beds. In some places, streams rush and cascade. In others, the river vanishes into the sand, leaving only silence. And if we live by one of the streams, we may never know how rare it is, how exceptional it is to inhabit a domain where the water of time flows at all. This is the existential horror hidden in the idea. We think of time as the stage upon which reality unfolds, but it may be only a local performance. In other theaters, there is no stage, no play, no unfolding. Reality itself might be patchy, stitched together from regions with and without time, like a cosmic quilt of temporal and atemporal fabric. And if that is true, then our very existence is precarious. Life depends on time, on the rhythm of change, on the arrow from past to future. Without it, chemistry stalls, evolution halts, thought is impossible. We are not just creatures of matter, we are creatures of time. Without its flow, we dissolve. The idea that time may be local transforms how we view ourselves. It humbles us, reminding us that our most intimate certainty may not be universal. It fills us with awe. To think that reality could be so much larger, stranger, and more fragmented than we can conceive. And it frightens us to consider that we may be perched on the edge of a temporal island, surrounded by gulfs of timelessness into which we could never step. The transition is inevitable. If time can vanish, then it is not alone. Time and space are entwined, partners in the dance of relativity. If one is local, perhaps the other is too. And so the next question rises like a shadow over the horizon. If time itself can fade, then might space too dissolve? It is tempting to imagine that space stretches on forever, smooth and uniform, an endless canvas on which galaxies and stars are painted. But what if space is not boundless, not continuous, not even fundamental? What if the very fabric we move through, the geometry that lets us speak of distance and direction, is itself stitched together unevenly, woven in ways that shift from region to region? In such a vision, space-time is not the eternal foundation of reality, but a fragile quilt, pieced together from smaller threads and perhaps torn at the seams. Modern physics whispers this possibility through the concept of emergence. Just as temperature is not a fundamental property, but arises from the movement of molecules, space itself may not be fundamental, but emergent, born from something deeper. In many proposals, quantum entanglement is the loom upon which this fabric is woven. Pairs of particles can become entangled, their fates linked across distance, so that measuring one instantly reveals the other. It is as if invisible threads connect them, threads that defy ordinary notions of space. Some physicists suggest that these threads are not merely curiosities, but the very essence of space-time. Where enough threads intertwine, they weave the geometry we recognize as space. Where the threads are absent, space itself may fray. If this is true, then space is not a given. It is a pattern, a tapestry that emerges only under certain conditions. Different regions of the cosmos may be woven from different patterns of connectivity, each with its own rules of geometry. In one region, space might feel smooth, distances behaving as expected. In another, the fabric might warp into bizarre forms, distances stretching or collapsing in ways that break our intuition. There may even be regions where space does not exist at all, where the threads of entanglement fail to weave, leaving behind a void more absolute than emptiness, an absence not of matter but of place itself. Take a moment to imagine this. Picture a great tapestry hanging in a dim cathedral. From afar, it looks uniform, a single expanse of cloth. But step closer, and the details reveal themselves. Some areas are woven tightly, the threads dense and strong. Others are looser, fragile, thin enough to let light pass through. In some corners, the fabric is missing altogether, ragged holes exposing the stone behind. Our universe may be such a tapestry. From the inside, it feels seamless. But on scales larger than we can see, or in domains far from our own, the weave may be irregular, stitched differently, perhaps even torn. The implications are profound. If space is emergent, then distance itself is a local concept. The idea that something can be far or near might only make sense within our patch of the cosmic quilt. Elsewhere, distance could be meaningless, or defined in ways we cannot imagine. 2 points that appear separate might be stitched together tightly, like folds in cloth that touch though they seem apart. Conversely, points that seem near could be disconnected, cut apart by missing threads, unreachable, not because of miles, but because the fabric between them is gone. This dissolves the notion of dimension. We think of space as three-dimensional, with length, width, and height forming the framework of reality. But if space is woven differently elsewhere, dimensions may not be fixed. Some regions might have 4, 5, or none at all. Others may shift, dimensionality rising and falling like tides. In such places, geometry is not a law, but a condition, as variable as weather. To travel there would not be to move through space, but to cross into different ways of being. The thought is difficult to bear, yet it is already whispered in our mathematics. In the study of black holes, entanglement appears to dictate the structure of space inside and around the horizon. In holographic theories, space-time itself arises from the entangled information of a deeper reality. These ideas remain speculative, but they reveal cracks in our certainty, suggesting that what we call the fabric of the universe may be no more fundamental than the patterns of frost on glass, beautiful and fragile, dependent on conditions we do not yet understand. Pause here and let the unease settle in. If space is not universal, then the stage on which existence unfolds is not permanent. Our sense of being here or there, our trust in dimensions and distances, may be parochial, a property of our patch, not of the whole. Step beyond, and the rules could dissolve. Walk in one direction, and the ground beneath your feet might stretch infinitely, never letting you arrive. Walk another way, and after only a few steps, you may find yourself back where you began, trapped in a loop of geometry that closes upon itself. To inhabit such a reality would be to inhabit a dream. The familiar order of near and far, left and right, up and down would vanish, replaced by an alien logic of connection. Consciousness itself might struggle to make sense of it. Our brains are tuned to three-dimensional space, evolved to navigate landscapes and hunt across plains. Place us in a world of shifting dimensionality, and even perception could unravel. What does it mean to see, to move, to think, when the geometry itself refuses stability? There is a quiet horror in this, and also a strange beauty. If space is not absolute, then our existence is not anchored in some eternal framework. We are wanderers on a temporary path, cradled by a local weave of reality. Beyond our patch may lie fabrics too strange to imagine, tapestries woven from alien patterns or torn into voids where no weaving exists at all. And yet we are here. Our patch has held. Its geometry has given us galaxies, planets, the delicate stability of life. In the fragility of this fabric lies the miracle of our presence. But the thought cannot rest. For if geometry changes, then not only are there different patterns of space, there may also be pockets where geometry gives rise to impossible worlds, domains where shapes defy logic, where cause and effect are distorted by the twisting of dimensions. Worlds that exist not as distant places, but as different fabrics altogether. And so the next question rises. If the geometry of space itself can shift, what forms of reality might such shifting create? There is a strange irony in the universe. The more deeply one studies its fabric, the more one discovers that it could have been otherwise. What feels inevitable, even natural, may in fact be precarious, balanced on the edge of alternatives so bizarre that they border on the unimaginable. For in the mathematics of string theory, in the landscapes of cosmological speculation, whole regions of existence may crystallize with laws utterly alien to ours. These are not simply exotic worlds like those of science fiction, but domains where the very possibility of anything familiar vanishes. String theory, controversial though it is, paints a picture of reality not as a single solution, but as a vast landscape of possible vacua, each defined by a different arrangement of extra dimensions, each with different constants and forces. If this vision is correct, then there is not one universe, but a multiverse of possibilities, each patch of reality frozen into its own set of laws during the cooling of the primordial cosmos. Some patches might resemble ours closely, while others would be unrecognizable, islands of impossibility adrift in a cosmic sea. What would such islands be like? Imagine a domain where electrons cannot exist, where the delicate balance of charges that allow atoms to form is forbidden by the rules of that patch. Without electrons, there are no atoms, no chemistry, no molecules to build stars or planets or life. Instead, such a universe would be an endless wash of featureless energy, perhaps punctuated by particles that never bind, drifting without pattern. Or picture a realm where black holes evaporate instantly. In our universe, black holes are monstrous anchors, devouring matter, bending time, their evaporation so slow that it outlasts the lifespan of stars. But in such an alien domain, the equations might dictate that no collapse can ever persist, that every attempt at forming structure collapses into a flash of energy and vanishes in an instant. There, gravity would never give rise to galaxies, stars, or planets. It would be a world where the script of cosmic evolution is erased before the first act begins. There may even be domains where no atoms form at all. Without stable nuclei, the periodic table is empty, a blank page where chemistry cannot write its poetry. Such a place would be sterile, not in the sense of barren landscapes or lifeless planets, but sterile at the most fundamental level, where matter itself fails to exist as anything but fleeting sparks. Pause here and consider the weight of this possibility. For every universe like ours, where complexity blossoms, there may be countless others where nothing takes root, where the conditions of existence never allow a single step toward order. These are not just deserts in the sense of being uninhabited. They are deserts in which the very notion of inhabitation is impossible, where no seeds can sprout, no rivers can carve valleys, no stars can burn. They are wastelands written into the mathematics of reality. This is cosmic horror at its most quiet and profound. To think that our universe, so lush with galaxies, life, and thought, might be only one oasis among an infinity of sterile sands. The more one reflects, the more fragile our own existence seems. We inhabit a narrow window, a balance of constants so delicately tuned that the slightest change would erase us. In one direction, atoms unravel. In another, stars never ignite. In yet another, space fractures into impossible geometries where structure cannot hold. Life is not inevitable, it is exceptional, a rare bloom in a garden where most soil cannot bear fruit. And perhaps this oasis is not permanent. If the constants of our universe are not eternal but shifting, then even our patch of fertile ground may someday drift into sterility. Perhaps the laws that allow atoms, chemistry, and consciousness are only temporary conditions, destined to fade. If so, then existence itself is a brief flowering in an otherwise barren expanse. There is beauty in this vision, but also an ache of loneliness. To imagine islands of impossibility scattered across the sea of the multiverse is to realize how isolated we are. Our world of galaxies and atoms is not the rule, but the exception. And exceptions by their nature are fragile. And yet, this fragility reveals something haunting. Why, out of all the impossible islands, are we here, in one of the rare places where the laws of physics permit life, thought, and wonder? Why does the universe seem so strangely fine-tuned for us, balanced on the edge of impossibility, yet tilted just enough toward order to allow the rise of minds that can question it? This is the riddle waiting at the horizon. If most of reality is sterile desert, then why do we inhabit an oasis? The question does not vanish with science, but deepens because of it. Physics, with its equations and constants, leads us directly into the mystery of fine-tuning, a puzzle that feels less like an answer and more like a door opening onto deeper uncertainty. And so, as we leave behind the barren islands of impossibility, we step into the next haunting thought. If rarity itself defines our existence, then we must ask, why? Why does our universe seem so strangely and precariously fine-tuned for life? There are moments when the universe feels almost too precise, as though it were a vast instrument tuned with impossible care. The stars that burn, the planets that form, the fragile patterns of chemistry that build life, all of these depend on numbers, constants that cannot drift even slightly without collapsing the stage we stand upon. Shift them by the smallest margin, and the harmony vanishes. And yet, here we are, breathing in rhythm with a cosmos balanced on the edge of impossibility. This is the enigma of fine-tuning. Consider gravity. It is weaker than the other forces by many orders of magnitude, and yet its weakness is what allows stars to live long enough for planets to form and life to emerge. If gravity were stronger, stars would burn too fast, collapsing in violent flashes before life could take root. If weaker, matter would drift apart, never condensing into suns or worlds. The line between too much and too little is razor thin, and we exist only because gravity rests exactly on that knife's edge. Or think of the charge of the electron. If it were even slightly different, chemistry as we know it would unravel. Molecules would fail to bond in stable forms, or the bonds would be so strong that no complexity could develop. Life, in all its subtle intricacy, depends on this single number being what it is. The universe does not advertise this fact, but in the quiet work of physics, the realization comes. It could have been otherwise. The list is long, and each constant carries the same lesson. the fine structure constant, which governs the strength of electromagnetism, cannot wander far from its current value without either unbinding atoms or binding them so tightly that chemistry stalls. The balance of forces in the nucleus of atoms, the ratio of matter to antimatter, the expansion rate of the cosmos, all are tuned with exquisite precision. Shift them by a fraction, and the universe becomes sterile. No galaxies, no stars, no life. Pause and breathe with this. For to sit with the idea of fine-tuning is to feel the weight of improbability pressing close. It is as though we live on a thin ledge overlooking vast abysses. On one side lies collapse, on the other emptiness, and only here, on this narrow perch, does life hold. The sheer unlikelihood of it leaves one with awe, but also with unease. For centuries, this enigma has carried a dangerous temptation to see purpose in the precision, design in the balance. It is easy, almost instinctive, to wonder if the universe was made for us, or if our presence is the point of its tuning. And yet, physics offers a quieter, stranger explanation. If the laws of the cosmos are not universal but regional, then fine-tuning is no longer miraculous. It is simply the consequence of variation. Picture a lottery, vast beyond imagination, in which countless numbers are drawn. Most are losing tickets, combinations that yield nothing but emptiness. But here and there, by chance, a ticket falls with the right sequence, and from it a world blooms. To those who live inside such a winning ticket, it feels like destiny. To those outside, there is nothing at all. The improbability of our existence dissolves when set against an infinity of trials. We exist not because the universe was designed for us, but because only universes like ours can contain observers to ask the question. This is sometimes called the anthropic principle, but names cannot soften its unsettling beauty. It means that the fine-tuning of our universe is not a miracle, but a condition of our perspective. Of course, we find ourselves in a cosmos that permits life, because only such a cosmos can give rise to beings capable of noticing. From the outside, it is only chance. From the inside, it feels like fate. And yet, there is a tension here, one that carries a whisper of dread. If fine-tuning is simply lottery, then it implies that most of reality is barren. Our oasis is not representative, but rare, a flicker of life amid infinite sterility. To live in such a place is to live surrounded by emptiness, knowing that our patch of fertile ground is fragile, and that there is no guarantee it will last. Consider the psychological weight of this. Humans have always longed to believe the universe has meaning, that it bends toward life, that we are not accidents but heirs to a grand design. But fine-tuning, seen through the lens of regional laws, erodes that comfort. It tells us we are local, precarious, the products of chance. Our existence may feel inevitable to us, but it is not. It is a consequence of inhabiting a rare corner where the dice happen to land in our favor. And perhaps this is where cosmic horror slips in. To know that infinite losing patches surround us is to feel a chill, a sense of isolation. We exist, yes, but we are islands adrift in a sea of impossibility. Our survival does not testify to purpose but to probability, and probabilities are indifferent. The universe did not have to include us. It does not have to keep us. Still, there is a quiet wonder in this perspective. For chance itself, given enough roles, has conjured galaxies, stars, and life. That we are here to ponder the odds is a miracle of a different kind. Not a miracle of design, but of abundance. Reality tried everything, and among the countless barren results, one was fertile, and we are its children. But the unease does not fade. For if we live inside a winning ticket, we cannot ignore the question that shadows us. What does it mean to exist in such a fragile oasis, surrounded by infinite losing ones? Does our presence grant meaning, or only emphasize the silence that lies beyond? The thought is not an answer, but a deepening of the riddle. And so we arrive at the next haunting step. If fine-tuning is a lottery, then rarity is our condition. But rarity raises its own question, perhaps the deepest of all. Why is there something rare at all, rather than nothing everywhere? Why is there an oasis when sterility would be the simpler outcome? Cosmic horror is often misunderstood. To most, it conjures visions of monstrous beings lurking in the darkness, creatures with too many eyes or tentacles reaching from the void. But those are only shadows cast by a deeper fear. True cosmic horror is not the presence of monsters, but the absence of care. It is the realization that the universe is not built around us, not designed for us, not even especially interested in us. It is the indifference of reality that unsettles most profoundly. This indifference grows sharper when one considers the possibility that the very laws of physics may be regional. For centuries, humanity has found comfort in believing that the rules of the cosmos are fixed and universal. The law of gravity pulls as it pulls, no matter where or when. The speed of light is constant, the charge of the electron unwavering, the laws unchanging across space and time. It is a vision of stability, of permanence, of something solid upon which to rest our fragile sense of belonging. But what if that vision is an illusion? What if we are not citizens of a vast and uniform cosmos, but temporary residents inside a fragile bubble of order, surrounded by expanses where the rules are otherwise? In such a picture, the universe becomes not a cathedral of symmetry, but a patchwork quilt stitched together from conflicting fabrics. Our little patch holds the familiar physics we know, but beyond its edges, everything unravels. To live within such a bubble is to feel suddenly small in a new way. We are not merely tiny specks lost in infinite space. We are tenants in a fragile domain, one that might have formed by chance, one that might dissolve just as easily. Our existence, once framed as improbable but secure, becomes contingent and unstable. The bedrock of reality reveals itself to be sand. Take a moment to feel that thought. It is not only science, it is philosophy sharpened into dread. For if the laws we know are not eternal but local, then the very notion of a law of nature dissolves. And what replaces it? If the cosmos is a shifting mosaic of domains, each with its own rules, then what is reality itself but a collection of temporary agreements? The question is no longer, what are the laws of physics, but why do we expect there to be laws at all? This is where the existential shiver creeps in, quiet but unstoppable. For to confront the indifference of reality is one thing, but to confront its possible lawlessness is another. The human mind craves patterns, structures, rules that can be trusted. We invent constellations in the stars. We carve formulas into stone. We teach children that the world is predictable. To imagine otherwise is to stand before chaos. It is to acknowledge that our search for meaning may be taking place in a realm that has no meaning to give. The philosopher Blaise Pascal once wrote of the eternal silence of infinite spaces and how it terrified him. But the silence he knew was only one of distance, of space stretching beyond comprehension. The silence we now glimpse is deeper, more profound. It is the silence of laws that may not exist, of rules that may hold only here, only now, and nowhere else. A silence not of emptiness, but of fragility. In that silence, the role of science itself shifts. Science has always been a map maker, charting the contours of the universe with equations and experiments. But what if there is no single map to draw, no single set of rules that govern all? Then science becomes not the act of discovering universal truths, but the act of documenting local customs. We are no longer writing the story of reality, but only the story of our neighborhood. And beyond our neighborhood, the language of reality may be so different that we could never translate it. Here is where the horror blossoms. If we are confined to our bubble, then our questions about the ultimate nature of reality may never be answered. We may never know why existence is stitched this way and not another, why laws emerge here but vanish there, why something persists when nothing would have been simpler. We are left with riddles that cannot be solved because the tools we use to solve them are themselves products of our local patch. The microscope, the telescope, the equation, the law, all may be provincial, blind outside our fragile bubble of order. And yet, despite this, we ask. We cannot stop asking. This is the paradox of the human condition. To live in a universe that may not care, but to care nonetheless. To search for patterns even when they may be illusions. To tell stories about why we are here, even when the truth may be that we are nowhere at all. This is where cosmic horror becomes not only unsettling, but strangely beautiful. For it reminds us that our search for meaning is an act of defiance. The universe may be indifferent, its laws fragile, its truths provisional, but still we seek. Still we build telescopes and theories. Still we look into the darkness and imagine answers. Our fragility does not silence us. It moves us to speak more softly, more urgently, into the vastness. Perhaps that is why these thoughts feel both terrifying and consoling. Terrifying because they strip away the illusion of permanence. Consoling because they reveal our resilience. Even if the universe is stitched from temporary fabrics, even if we live in a bubble that may one day dissolve, still we have lived, still we have wondered, still we have asked questions that echo into the silence. The existential shiver is not the end of the story. It is the beginning of a deeper one. For if the laws of physics are not universal, then reality is stranger than we can ever know. And in that strangeness lies an abyss, one final mystery that beckons us forward. And in that thought, one final abyss opens. It is one thing to imagine that the universe's rules are regional, stitched differently in distant domains, far away from our eyes and safely beyond our reach. That alone is enough to send a tremor of unease through the human mind. But there is a darker possibility, more immediate, more intimate. What if the rules of our universe are not only regional, but also temporary? What if the physics we trust, the constants we depend upon, are not permanent structures at all, but fragile contracts destined to expire? This is where cosmology brushes against its most unsettling idea, vacuum decay. It begins innocently, in the language of quantum fields. The universe we live in is not empty, but filled with invisible fields that ripple beneath reality. These fields define the particles, the forces, the very texture of existence. Our laws of physics are written into their shape. But shapes can be unstable. A field can settle into a state that feels permanent, while secretly hiding a deeper, lower state of energy. Like a boulder balanced on a hilltop, our universe may not be in its true resting place, but only in a precarious perch. If that is so, then all of physics is vulnerable. Because in the strange logic of quantum mechanics, even the most stable perch can eventually give way. The universe can tunnel through the hill, suddenly dropping into a new valley of lower energy. In that instant, the rules that define our existence, the speed of light, the strength of gravity, the interactions of particles, would all be rewritten. It would not be death in the ordinary sense, not even destruction, but something more chilling. The erasure of everything that was, replaced by something alien, incomprehensible, and silent. Scientists call this vacuum decay, but the name is almost too clinical for what it implies. Imagine space itself trembling, and then a bubble forms, tiny, invisible, yet expanding faster than light. Inside that bubble, the laws are different. Chemistry is gone, atoms cannot exist, time itself may not flow as we understand it, and the bubble does not pause. It grows, racing outward, consuming everything in its path. Galaxies vanish not in fire, but in silence. Stars are rewritten, planets dissolve, life is unmade. And because the bubble spreads faster than light, there is no warning, no escape. One instant the universe is as it has always been. The next it is something else, and there is no one left to notice. The ultimate horror is not death, but irrelevance. Death is at least an event that happens to someone, a thing that can be witnessed or mourned. Vacuum decay allows no witness. It is not an ending within the story. It is the ending of the story itself. The page is not turned, it is erased. Take a moment to feel this. To sit with it is to realize that the fragility of our universe is more profound than the fragility of life within it. We are not only mortal beings, but inhabitants of a mortal cosmos, one that may not endure. All that we build, all that we know, may one day dissolve not in the long heat death of entropy, but in the sudden rewriting of the very rules we assumed eternal. And yet, it is not only terror that follows from this thought. There is also wonder, for if the laws themselves are contingent, then reality is not a fixed stage, but a living process. It breathes, it changes, it risks collapse. It reminds us that permanence is an illusion, that what we call eternal truths are only temporary arrangements. The horror lies in their instability. The beauty lies in our ability to glimpse them before they vanish. There is also, strangely, a kind of comfort. Vacuum decay, if it comes, will be instant. No pain, no suffering, no time even to realize what is happening. One moment we are here, the next we are not. The abyss is absolute, but it is mercifully swift. For a universe that has no concern for us, perhaps that is the closest thing to kindness it offers. And perhaps in another way, the idea of vacuum decay humbles us into gratitude. Every second that passes without the rewriting of the laws is a second of borrowed time, a gift we did not earn. To live is to inhabit a fragile patch of stability, knowing it could collapse, but choosing to sing within it anyway. Our poetry, our science, our tenderness toward one another, these are not meaningless in the face of instability. They are radiant precisely because of it. They are the flickers of light inside a fragile bubble. This is the paradox of cosmic horror. The more fragile the universe appears, the more precious each moment within it becomes. The threat of erasure sharpens the value of what is, right now. Every star above, every breath we take, every story told under the night sky, they are not diminished by the possibility of collapse. They are illuminated by it. Still, the thought lingers like a shadow. What does it mean to live in a universe whose laws may expire? What does it mean to build meaning in a cosmos that may be rewritten in silence? There is no final answer, only the deepening of the question. The abyss is not something to solve, but something to feel. It is the background hum beneath all existence, a reminder that nothing is promised and everything is fragile. And perhaps that fragility is the true essence of cosmic horror. Not monsters, not darkness, not even death, but the knowledge that the ground beneath reality can shift without warning. That our bubble of order is a brief and local miracle, and that one day it may burst. But let us not end only in dread. For in this darkest abyss, there remains a strange kind of comfort. Comfort in the awareness that we are here now, that the laws still hold, that the fragile bubble has not yet burst. Comfort in knowing that even if the universe is impermanent, we are part of its fleeting beauty. Comfort in the thought that fragility does not erase meaning, but creates it. The abyss yawns, but so does wonder. And in this balance between terror and awe, we find the quiet heartbeat of existence itself. The journey through these questions has been long, winding, and at times unsettling. We have walked through cosmic patchworks and fragile constants, through voids and collisions, through the possibility of laws that change, dissolve, or collapse. Each step has revealed a universe stranger and less certain than we might have hoped. And yet here, at the quiet end of that road, we arrive not at despair, but at something softer, something almost luminous. Our universe may be rare. Its laws may be precarious, its constants may be balanced on the narrowest of ledges, but still, it is ours, and that is enough to make it precious. Consider for a moment the unlikely generosity of our patch of reality. Gravity, fragile in its weakness, allows stars to burn steadily for billions of years. The electromagnetic force, tuned with uncanny precision, lets atoms bond into molecules, molecules into chains, chains into the chemistry of life. Water flows in liquid rivers, oceans lap against rocky shores, and above them, air carries whispers, songs, and laughter. And within this fragile balance, minds arise. Minds capable not only of survival, but of wonder. If physics is regional, then we dwell in one of the rare gardens where order blooms. Countless other regions may be barren deserts, or storms of chaos, or stillborn realities where nothing persists at all. Yet somehow, against odds that stagger imagination, we find ourselves in a place where galaxies spiral gracefully, where suns warm their planets, where life grows, thinks, and dreams. Perhaps this is not destiny. Perhaps it is only chance. But chance, when seen from the inside, feels like miracle. There is beauty in fragility. We often imagine miracles as permanent, unchanging, beyond the reach of time. But the true miracle may be the opposite. A soap bubble is more beautiful because it shimmers only for a moment before vanishing. A snowflake is more intricate because it melts in the warmth of the hand. So too with our universe. Its laws may not endure forever, but while they hold, they give us stars to gaze upon, rivers to drink from, and one another to share these thoughts with. To see the cosmos as fragile does not diminish its wonder. It deepens it. Permanence would make the universe indifferent, inevitable, a stage that would always exist no matter what. Fragility makes it fleeting, unrepeatable, infinitely precious. The fleeting beauty of order rising from chaos is perhaps the greatest miracle of all. Take a moment here. Close your eyes if you wish, and let the thought sink in. You are alive, right now, inside a rare and delicate patch of reality. The constants align, the forces balance, the laws permit you to breathe, to listen, to wonder. This moment, however small, is built upon a cosmic harmony that may exist nowhere else. That harmony does not have to last forever to be meaningful. It only has to last long enough for us to notice it, to marvel at it, to whisper our gratitude into the silence. When we imagine the end, whether by entropy or vacuum decay, whether by slow fading or sudden rewriting, it is easy to feel despair. But perhaps it is better to feel tenderness. For even the possibility of an ending reminds us that everything we cherish is already an improbable gift. To love, to create, to dream, to share our stories. These are not diminished by impermanence. They are illuminated by it. Fragility is not the enemy of meaning. Fragility is its source. And so we return to the question that lingered earlier. What does it mean to exist in a winning patch, knowing infinite losing ones surround it? Perhaps it means that existence itself is the miracle, that being here at all is enough, that in a universe where chaos is the rule, the appearance of even a fleeting island of order is something sacred, something worth cherishing. It is tempting, in the face of cosmic horror, to recoil, to feel only the dread of insignificance, the chill of indifference. But if we look again, if we soften our gaze, we see something else. We see that insignificance is only one story. Another story is that of belonging. Not because the universe was made for us, but because we are part of it, stitched from the same fragile fabric, shimmering in the same fleeting light. And perhaps that is the gentlest truth. We do not need permanence to matter. We do not need certainty to love. The cosmos may not be eternal. Its laws may not be universal. But while they hold, they are enough. Enough for starlight. Enough for oceans. Enough for life. Enough for us. As we draw to a close, let the rhythm slow. Let the thoughts settle like dust drifting in sunlight. The universe is vast, fragile, and strange. It may one day dissolve into silence, but for now, it sings. And we, improbable listeners, are here to hear it. That is the miracle. Not forever, not always, but here, now. So let the mind rest in that thought, like a ship anchored in calm waters. The abyss still exists, the questions remain, the mystery endures. But within our fragile bubble, we have warmth and wonder and the quiet beauty of a fleeting miracle. And as the last words fade, imagine the cosmos itself exhaling, dimming, resting. The stars above, the earth below, the breath in your chest, all held by a fragile harmony that will not last forever, but does not need to. For in the end, the truest comfort is this: even fragile things can shine. Whisper it softly, as though to the universe itself. Thank you.